Welcome to The Explainer. I am so thrilled you're tuning in. Today, we're focusing on something that is, well, it's secretly the ultimate cheat code for understanding our universe: math. Yeah, I know, but stick with me. It isn't just dry numbers on a page, it is literally the invisible architecture of the physical world around us. We aren't going to be memorizing boring formulas today, no way. Instead, we're going to see how math is actually a highly visual toolkit for decoding the realities of everyday life. We're taking those invisible rules that govern our environment and making them undeniably visible. Okay, let's dive into this and unlock your real-world math toolkit. We'll be hitting 4 quick steps today: measuring the physical world, balancing the algebraic scale, math for financial literacy, and finally, building your math toolkit. Let's get right to it. Section 1. Measuring the physical world. Let's look at some absolute geometry gems. In the past, we might have just recognized shapes, but now? Now it's time to actually measure them. So imagine this. You're putting in a fence for a brand new dog, and your backyard is a rectangle. Let's say it's 10 feet long and 5 feet wide. How much fencing do you actually need? You see, you aren't just solving some abstract math problem right now, you're executing a real weekend DIY project. You absolutely need to know the physical boundaries of your space. And the solution to our dog fence dilemma relies on perimeter. That's the total distance around the outside of a shape. Try to think of it as a dynamic physical action, right? It's like unrolling a giant tape measure and physically tracing the boundary of your yard. For our specific setup, you just add up those sides, and that sums to 30 feet of fencing. Boom, you've just used geometry to successfully navigate a physical constraint. And this brilliantly illustrates the critical difference between a boundary and a surface. Perimeter is the fence, sure, but area? Area is the grass filling the inside of that fence. Or think of painting a room. An 8 by 12-foot wall doesn't just require an outline. To get enough paint, you need to figure out the total surface area, which is 96 square feet. Moving right along to Section 2, balancing the algebraic scale. We're transitioning from the physical 2D shapes of geometry into the seemingly invisible world of algebra. Time to make those abstract concepts visual. Isolating an unknown variable. I know, it sounds super intimidating, right? But while it is the core goal of solving linear equations, it's really just detective work. You have a mystery, and your mission is to strip away all the extra noise until that unknown stands completely alone. Let's move to this and see how this builds into a really helpful analogy. Think of a linear equation as a physical balance scale. First, just picture that scale in your mind. Second, identify your unknown variable. That's your mystery weight. And third, apply the golden rule of algebra. Whatever you do to one side of the scale, you absolutely must do to the other to keep it perfectly balanced. It takes this abstract, tricky math problem and turns it into a highly visual, step-by-step physical balancing act. All right, Section 3, Math for Financial Literacy. Let's pivot from equations and talk about the ultimate real-world scenario: managing your wallet. Applying these problem-solving skills to real-world financial realities is just incredibly empowering. The crazy thing is, the exact same logical rules we just used for geometry and algebra, measuring boundaries, keeping scales balanced, they apply directly to resolving complex personal finance problems. Budgeting is literally applied mathematics in action. Now, what's really interesting about this slide is how creating a budget relies entirely on those percentages and ratios we've been talking about. Take a look at this breakdown. We're dividing the pie into 50% for essential expenses, 30% for discretionary spending, and 20% for savings. You're taking your total resources and mathematically balancing the scale to ensure you always have enough left over. Which brings us to Section 4, building your math toolkit. Let's empower you with some hands-on virtual manipulatives. To really put all of this into practice, you've got to check out specific digital resources like Illuminations, the National Library of Virtual Manipulatives, and Polypad. These aren't just basic calculators, folks. They are interactive models. Tools like Polypad, for example, actually allow you to design and calculate dimensions for your own digital gardens in real time. It puts the math literally right at your fingertips. So the crucial point is this: math is absolutely not confined to a classroom whiteboard. It's the language of the space you occupy right now. Take a quick look around the room you're in at this exact moment. What is one problem you can solve using your newly unlocked algebraic or geometric toolkit? Are you maybe calculating the area for a new rug or trying to balance a budget for an upcoming trip? Take these tools and start measuring your world. Thanks so much for joining this explainer, and keep exploring.